Good day, student. These are the objectives we'll be looking at under indices. And the objectives are, first of all, look at the concept of indices. Look at the 4 laws of indices, the 4 properties of indices, and simplifications of indices. So these are the things that we'll be looking at today. Now, under the concept of indices, we are saying that given that a exponent n, where a is any real number and n is also any real number. Also, n can be an integer, being it a positive number or a negative number. So let's say n can be from, let's say, a certain negative value set of values to a certain positive set of values. So n can be any number. Now, the name of a is called base. We pronounce a as base and we pronounce n as index. Now, the plural form for index is what we call the indices, which came up with this topic, indices. Now, n can also be pronounced as exponent or sometimes power. So, let's look at the relationship between a and n. The relation between a and n means that the integer n you see there, the n here, tells you that the base a, this base a, will multiply itself n times. So what we are trying to say is that, let's look at this. If I have a raised to the power 3, a raised to the power 3 means that a will multiply itself 3 times. If I have p raised to the power 5, it means p multiplies itself 5 times. And we have the last one. So this is the nature of indices. So let's look at this one too. If I have 2 exponent 4, it means 2 will multiply itself 4 times. And some students will do it this way, assuming 3 raised to the power 2. Most students think that because, let's look at this one, because 2 raised to the power 2 is 4, most students think that this 2 was multiplied to this 2, so they had 4. So on that note, when you ask them that 3 exponent 2, the student will say 6, which is wrong. Okay, which is wrong. It shouldn't be so. 3 exponent 2 means that 3 will multiply itself 2 times. Okay, and the result is 9 and not this. So please, you should take very good care whenever you are dealing with base and its exponent. Don't ever multiply the base to the exponent. Always multiply the base to itself based on the exponent that you have. So if you have, let's say, 3 exponent 7, 3 exponent 7 is going to be 3 multiplying itself 7 times, because we have 7 here. So 3 by 3 by 3 by 3 by 3 by 3. Let's see, we have 1 2 3 4 5 6. We are left with the last one by 3. So 3 multiplying itself 7 times. Now let's look at the laws of indices. Now the first law, that's law 1. I call it the addition law of indices. And the addition law of indices is saying that, the theorem is saying that given, let's say, a base of a to an exponent of m, multiplying the same base of a to another exponent of n. The law is saying that because we have a here and a here, because these two bases are the same, you have every right to write one of them and add the exponent together. So we have m plus n. Now let's support this thing with an example. Let's look at this. Let's say we have 2 exponent 2 multiplying 2 exponent 3. 2 exponent 2 multiplying 2 exponent 3. 2 exponent 2 is the same as 2 times 2, which is also the same as 4. 2 exponent 3 is the same as 2 by 2 by 2. Let's put this in brackets, which is the same as 8. And 4 times 8 is 32. 4 times 8 is 32. So let's ignore these steps and let's go by what the theorem is saying. The theorem is saying that if you have 2 exponent 2 multiplying 2 exponent 3, 2 exponent 2 multiplying 2 exponent 3, because we have 2 here and we have 2 here, you can hold 1 2 and add the exponent. So we have 2 plus 3, and 2 plus 3 is 5, which is true, because this 32 you see here, you can express this 32 in terms of 2. That's 2 by 2, which is 4. 4 by 2 is 8. 8 by 2 is 16. And 16 by 2 is 32. So we have 1, 2, 3, 4, 5. So you can see that 2 has been expressed how many times? 1, 2, 3, 4, 5. That's this. So you can see that we have the same answers, which has buttressed what the law 1 is saying. So if you are given any question whereby you have 2 same base, the only thing you can do is to add the exponent. So let's look at this simple one too. Let's say 5 by 5. 5 by 5, we know that 5 by 5 is 25. But indices is saying that you can also express this result as 5 1 plus 1, which is 5 exponent 2, and 5 exponent 2 is the same as 25. Another example, let's look at this. Let's say we have 3 exponent 2 multiplying 3 multiplying another 3 exponent 4 multiplying 3 exponent, let's say 3. Now because we have 3 throughout, all the base are the same, you can write one of them and add all the exponents here. Now this 3 here is having an exponent. Despite the fact that we can't see the exponent, does not mean it's not having an exponent. It's having an exponent, which is 1. So if you can't see the exponent is 1. Okay, so we have 3, then we add all the exponents we have up here. We have 2 here, plus we have 1 here, plus we have 4 here, and we have 3 here. So the answer to the problem becomes 2 plus 1, which is 3, plus 4 is 7, and plus 3 is 10. So this is the answer to the problem. Now let's look at this example 2. We have 4 exponent 3 multiplying 2 exponent 5 multiplying 2 exponent 2. Now this 4 here can be expressed in terms of 2. So let's express this 4 in terms of 2. We just want to apply the law of indices. So 4 can be written as 2 times 2. Don't forget that the 4 is having an exponent of 3. We have 2 exponent 5. We have 2 exponent 2. Now because this exponent is there for these two people, so you can share it for them. Each of them gets its own exponent. So you can clearly see that we have 2 throughout. So you can keep 1 and add the exponent you have up here. So 3 plus 3 is 6, plus 5 is 11, and plus 2 is 13. And this is the answer to the problem. Now let's look at this example. Now we have 2 exponent 3 multiplying 3 exponent 2 multiplying 2 exponent 5. So with this 2 exponent 3, 2 exponent 5, and 3 exponent 2, we just group. So those we choose will go to one side, and those without the base 2 also go to the other side. So we have 2, 3 plus 5, which is 8, multiplying 3 exponent 2. Now the law did not say that when you have 2 and 3, you can add the exponent. The law did not say that. What the law said was, if the bases are the same, you can add the exponent. In this case, the bases are not the same, so we can't add the exponent. So you leave your answer like that. Now the law 2, I call the subtraction law of indices. And the law 2 is saying that, let's get the law 2. The theorem is, if you have, let's say, let's consider p exponent a divided by another p exponent b. Because the bases are the same, this thing can be expressed as p a minus b. Similarly, if you have p exponent a divided by p exponent b, it can also express as p exponent a over p b, which is the same as p a minus b. We can only do this when we have equal base. If the bases are not equal, don't do it. So what they are trying to say is that if you have, let's say, a m divided by k y, because a is not the same as k, you can't subtract y from m. No, you can only subtract when you have equal base. So let's pick out an example. Let's say 5 exponent 6 divided by 5 exponent 2. Because of this law, we can solve this problem quickly by saying that 5 exponent 6 divided by 5 exponent 2 is equal to 5 6 minus 2, which is equal to 5 4. 5 exponent 4. Or this problem can be resolved this way: 5 6 divided by 5 2. Now we have 5 multiplying itself 6 times, so 5 by 5 by 5 4 5. So 1 2 3 4 5, and the last one all over 5 multiplying itself twice. So we have 5 here, so they will cancel each other. This cancels this, this cancels that. So you'll be left with 1 2 3 4. Then go back to the addition of indices, which is saying that if the bases are the same, you can add the exponent. So 5 here, we have exponent 1 plus 1 plus 1 plus 1, making 4. So this is the same as that. Now let's look at this case. We have 2 exponent 4 multiplying 2 exponent 5 multiplying 2 exponent 3, all divided by 2 exponent 2 multiplying 2 exponent 2. Now because we have equal base, we keep one of the base and we add the exponent. 4 plus 5 plus 3. 4 plus 5 is 9, plus 3, we have 12. We have equal base, so 2, we add the exponent, making 4. Now this sends us back to what division is saying. Division is saying that if the bases are the same, you hold one of the exponent, then you subtract the denominator, the exponent of the denominator, from the exponent of the numerator. So you have 12 exponent 12 minus 4, we have 8, 2 exponent 8. So this is what we have. Now the law 3, I call the power law. The power law is saying that if you have, since when you have, let's say, x exponent, let's say 3, it means the x here is being influenced by the power 3 here. So that's x by x by x. The same way, if you have ab exponent 2, it It means AB here is being influenced by these two here. That's AB multiplying AB twice. If AB is having an exponent of 3, AB will multiply itself 3 times. Conversely, a theorem is also saying that if I have MK multiplying itself twice, this MK here can be written as this MK. Now, because this thing is product, you can switch all m's to one side, so m by m, and switch all k's to one side, k by k. Now, how many m's do we have here? We have 2 m's. How many k's do we have here? We have 2 k's. So what we are trying to say is that if you have any number, let's say a b exponent 5, AB exponent 5 is the same as A multiplying itself 5 times and B multiplying itself 5 times. So with this case, you can see that we have an exponent of 3, and how many A's do we have here? We have 3 A's. So A multiplies itself 3 times. And how many B's do we have here? We have 1, 2, 3 B's. B multiplying itself 3 times. So each of these variables will be treated separately from the other variable as far as considering each of the exponent. So when I have a, b, c exponent 4, it means A will reflect 4 times, B reflect 4 times, and C also reflect 4 times. That's the meaning of this. Now let's look at this example, 3 by 4 exponent 2. Now because of what happened, we can say that the square affects the 3, so 3 will appear twice and 4 also appears twice. That's the meaning. Or let's say let's look at this theorem too. If you have A on B all having an exponent of, let's say, m, A on B having an exponent of m, this thing we see here means that A is being influenced by the exponent m and B is also influenced by the exponent m. So if you have 2 on 3 all exponent 4, 2 here is being influenced by the exponent 4 and 3 is being influenced by the exponent 4, and this gives us, you have 2, 2, 2, 2, 2 is 4, 4, 2 is 8, you have 16, and we have 81. Yeah, we have 81. So that is it for the law 3. Now the law 4 is saying that given A exponent 2 all in bracket exponent 3, this thing we see here means that A exponent 2 multiplies itself 3 times. So because the base are the same from the law 1, the addition law is saying that if you have equal base multiplying themselves, then you have every right to hold one of the base and add to the exponent. So you have 2 plus 2 plus 2 making 6. On that note, then we can also say that if I have A exponent 2 multiplying 3, A2 multiplying, having an exponent of 3, this thing here means that A2 times 3 A6. Then this one too is true. If this is true for this, then this should also be true. So that's the meaning. So if I have, let's look at this example. If I have, let's say, 3 exponent 2 exponent 4. Since this is the same as 3 exponent 2 times 3 exponent 2 times 3 exponent 2, reflecting 4 times, then I have every right to hold 3 exponent 2 and multiply the 2 by the exponent of 4 here, making 3 exponent 8. And this is the same as you writing 3 exponent 2 4 times. So in a nutshell, we are saying that, let's write it here. We are saying that given a exponent m exponent n is the same as a m by n. This is what we are trying to say. Now let's look at this final case. We have 2 exponent 3 multiplying 3 exponent 6, 2 multiplying 3 exponent 5 from the denominator, all exponent 2. So we solve this question systematically. So let's look at it. We have 2, 3 here, multiplying 3, 6 here. So we treat this as 1 and 2 by 3, 5 exponent 2 as 1. Now we are going to treat each of them with this exponent. So from what we know, we have 2, 3 here, exponent 2, 3, 6 here, exponent 2. The same thing happens 2 exponent 2. Don't forget that we have 1 here. The exponent here is 1. And we have 3, 5 here, exponent 2. So 2 exponent 3 exponent 2 becomes 2, 3 times 2 making 6. 3 here, exponent 6 times exponent 2 making 12. 1 times 2 making 2. 5 times 2 making 10. Now from here, we can split this. Treat the 2's to one side and treat the ones without 2's, or the 3's to one side. We have 2, 6 here and 2, 2. Multiplying 3, 12 here and 3, 10. Now from here, we know what division said. Division said that if you have the same base for division, then you can subtract their exponent. That's the exponent of the denominator from the exponent of the numerator. So we have 6 minus 2, and we have 3 here, 12 minus 10. So what do we have? We have 2, 4, multiplying 3, 12 minus 10 is 2. I think from here you can rest here because you can't do anything to this problem again.